Yesterday, you guys did this with sentences and looking at this and evaluating what the sentences do, and I still need you to know how to do that. You've got to know how to translate all of these into sentences and get those sentences to have a meaning behind it. Sidebar, I've not figured out how to get that clicky thing out of the way, so I might just end up switching programs. I use a screencast because that's going to bug the heck out of you the entire period. Sorry. Just let it happen. Allow yourself to have that moment where you freak out from the light show. And those watching this on video have no idea what I'm talking about because to them it just looks like a nice little counter ticking in the corner. In any case, Algebraically is kind of the name of the course. So we're not going to always take things and convert them and show them that way. We are going to do this in a very logical way. And I want to start off, thank you, with this. So we did translate that before to mean a number's distance from 1 is 7 units. And then if we're 7 units away from 1, we go 7 to the right and 7 to the left, and that's fine. That's a very literal interpretation of what you're seeing. The algebraic interpretation is similar, albeit just a little bit more mathematical. This here actually kind of means, and I'm going to write this here, this means the thingy, I'm going to use the word thingy, you can go with it, the thingy inside the bars. So that means this thingy right here, that's the thingy. That thingy must, not in highlight, must be either what or what. So this x minus 1 thingy in here has to be what number? Well, let me remove it for a second and let's see if you can kind of, when it's removed, can you tell me what it must be? What could go in there to make this sentence true? Calvin?
7.
Okay, good. 7. What else could?
-7.
-7. 2 possibilities. There are 2 possibilities for every time that you have an absolute value. Every single time you do an absolute value, you have 2 possibilities. This is one possibility. This is the other possibility. And it's not that you're changing 7 to be positive or -7. It's that you're saying the thing inside, or the thingy inside the absolute value, could be 7 or it could be -7 to make this true. We just need to figure out what 2 x values make that true. That's the easy part. X equals 8 or x equals -6, which we're going to put in set notation as -6 or 8. But the key thing here was going to the 2 possibilities. So you need to really, really know and hone this. Every time you have absolute value, there are 2 possibilities. Every single time they have absolute value, there are 2 possibilities. This is the 5th time I've actually said this, so if you haven't gotten to writing that down somewhere in the margins, then you're like a terrible annotator. If ever a teacher says something more than twice, write it down, because that will come up at some point. Every single time you have absolute value, there will be 2 possibilities. You need to account for both possibilities. So let's change this up on you and present you with a very logical algebraic way to solve an absolute value inequality. As I wrote to your parents today, this is the part of the semester so far that should feel new. We did not do this in Algebra 1 here. I really doubt you guys did it in middle school Algebra 1. And yet this is the start of our discussion of distance, is how this actually works. So this sentence right here, this is an open sentence describing an idea. The thingy, which is this thingy, and I'll highlight it in a fainter color. Let's go light blue. That thingy, inside the bars, must be more than 5. That's one possibility. What else could it be? It has to have a bigger value than 5. Or, Nelson?
-5.
What about it?
Could be -5.
It actually can't be -5, but what's the equivalent? Say on this. More than 5 or?
Less than -5.
That's the one I'm going for. Because more than 5 means a bigger number than 5, a bigger positive number. Well, what's a bigger negative number? That's left of negative 5, right? Negative 6, negative 7, negative 8. Those are bigger negative numbers. If I have a car that's going 70 miles per hour and another car is going negative 70 miles per hour, doesn't that just mean 70 in a different direction? They're both going 70. That's the idea of magnitude, and that's what this applies to. More than 5 or less than negative 5. Both of those are the same idea. That's what this is saying. The thingy inside the absolute value has to be numbers that are bigger than 5 or numbers that are smaller than negative 5. Because once you take their absolute value, you're going to get numbers that are greater than 5. Which translates to greater than 5 or less than negative 5. This is still the thingy inside the absolute value. And I'm going to make this be a little bit more reddish, so you probably won't see too bad there. No, you won't. We'll make it orange. Because what happens here is a sign switch in two directions. Greater than 5 equates to less than negative 5. I think about it as we took this, switched it, took that, swapped it. Switch the sign afterwards, and you get an equivalent statement on the other side. This equals right here. So we'll go yellow. That's a little too power yellow for me. More colors. Let's go pastel yellow. That's better. This translates to the word or. Distance is bigger. Distance is bigger means either we're going this way or we're going this way. We're further away from. And the idea that a greater than translates to an or, I really do wish that there was a way to remember easily that a greater, I'm going to misspell it, sorry, a greater goes with an or statement. If only there was some way that I could remember that greater goes with an or, then I would write it down for you. But I'm not, because I don't believe in memory tools. Well, let's solve both of these. X is greater than 6 or x is less than negative 4. Okay, do we need to graph that, or is there overlap? Maybe we swap this around to make sure that it's x is less than 4 or x is greater than 6. Is there overlap at all there? Okay, it's an or statement, so we're okay to kind of set that aside as our set notation. I do want you to see this graphically, that negative 4 and 6 would be going in this direction, but you do not have to graph your final answer. I'm just showing you there is no overlap on that. So that's why our final set notation is what this is asking for. So that's the process. Let's try it again with a different one. So I'm being way too indecisive on colors. Negative absolute value of 2x plus 5 less than or equal to 5. Before I actually start solving this algebraically, I have to deal with something that I might not want to deal with. That thing. We know that we can multiply both the left and the right side of an equal sign or an inequality by a negative number. Just what happens? Yeah, that's going to switch. That's fine. So we're going to get 2x plus 1 is greater than or equal to negative 5. There's a way to see a solution here right now. And if you see it, you can actually put the solution and skip all of the work we're about to do. But I do want to show you that if you do the work that we're about to do, you're going to get the same result. It's just going to take just a tad bit more time. And then we'll kind of cycle back, and when you see that, you can go back and say to yourself, oh, I should have seen that. This is going to translate as 2x plus 1 is greater than or equal to negative 5. I will get there. If you see it, I'm glad to be happy. Just, what does this word translate to? Is that and or? Or. It's a greater. And then we have 2x plus 1 is less than or equal to a positive 5. We switch the signs and switch the signs around. I'm going to solve the first one. I'm going to solve the second one. I am going to graph these because I'm being stubborn. I'm going to put these on here. Let's put -3 and 2. I'm going to consolidate this. Greater than or equal to -3, less than or equal to 2. This is an OR statement. What does the OR look like? Or something that overlaps like that? This is in all real numbers. Delaney, how could you tell that?
Well, I was gonna say that the absolute value can't equal negative, but then I realized that it's like a greater than, so then I realized it was all real numbers.
Yeah, the absolute value will always be greater than a negative number. The very smallest an absolute value expression can ever be is 0. It's either going to be 0 or positive. So if the left side is 0 or positive and the right side is negative, that will always be true, no matter what you plug in. So whether you see it here after going through all that work, or whether you see it way up here after looking at that and saying, hey, that has to be real numbers, either way works, and I do not need to see the work underneath if you see it at the top for stuff like that. I don't. You can use your noggins and kind of get there. Number 4. 1 minus absolute value of 3x minus 1 greater than or equal to -15. Sometimes you have a little bit of work that you have to do, like in this. We need to isolate the absolute value. People won't always do that. They'll try to split this into two things, and to me that says you kind of need to go back to basic equation solving. We're always trying to do what's done to the variable in reverse order. That's like the essence of equation solving. Very first time you ever learn equation solving, you do what's done to this variable in reverse order. What is done to that variable? Multiply by 3, subtract 7, absolute value, times negative, plus 1. We undo all that in the reverse order that it was done. So the first thing we have to deal with is what? Subtract 1. We got to get rid of that 1. Minus 1, minus 1. So you have a negative absolute value of 3x minus 1 greater than or equal to -16. Then before we even touch the absolute value, we have to get rid of this negative. We can never go back inside absolute value, especially not with a negative. So divide both sides by negative causes something monumental to happen. This becomes less than or equal to 16. This is our first time we've seen the less than or equal to, so let's do a little sentence thing off to the side. Ooh, I'll do it below, so it actually makes sense. The thingy inside the bars the thingy inside the bars has to be less than 16. That's true. But what's the equivalent statement in absolute value on the other side of the number line? Less than 16 means it has to be smaller than 16, like 15, 14, 13, 12, 11, 10. Yep, more than -16. And what is it? Is there another word I can say that means less than 16 but also more than -16?
Like
between. We're going to be between those two. The thingy inside the absolute value is in between -16 and 16. That's going to make sure that it has values that are smaller than 16. Absolute values. You have two options on solving this. We're going to do both for the same problem, so you can kind of play out which in your head works. They're both the same thing, really. The one option is to do exactly what we did before. Split it into two statements. 3x minus 1 is less than or equal to 16. I'm not going to put the word or, because this in between doesn't look like an or statement. It looks like an and statement. So I'm going to write the word and, or put the intersect symbol, but I like the word and right now. 3x minus 1. Switch the sign, greater than or equal to, and switch the sign again, negative 16. We'll solve both of these. 3x is less than or equal to 17. X is less than or equal to 17 thirds. I'm going to keep the word and going down because we like that word. 3x is greater than or equal to negative 15. X is greater than or equal to negative 5. Then you just have to ask yourself, does it make sense for a number to be greater than a negative and less than a positive? Could it be in between those two? Is that what this is saying? Greater than a negative, I'm going to do this graph kind of together. Negative 5, 17 thirds. One of them goes this way. One of them goes this way. And this is an and, so it's all the in-between. This really translates to negative 5 less than or equal to x less than or equal to 17 thirds. That's the set notation solution for that. While you guys are writing that, I wish there was a way to remember that when an absolute value was less than, that it would mean an and. It would be very, very, very nice if there was like an easy way to just mentally remember that whenever you have a less than, that's an and. Oops, I put another letter at the end of that. I didn't mean to do that. Less than, greater. Capiche? I didn't make that up, but I will steal it. I did say there were two options. That's one of them. Here's the second. And if you ask me which one's better, this one is. It goes back to the idea that the thingy inside the absolute value is between negative 16 and 16. I can actually skip right away to say that it's in between negative 16 and 16. I can create one of these, which you've seen before. That's what in between means. Then we're going to add 1 to all three sides. Oopsie. And get negative 15 is less than or equal to 3x, which is less than or equal to 17. And then divide all three sides by 3. Negative 5 is less than or equal to x, is less than or equal to 17 thirds. Put an x in front of. Note that it's exactly the same solution as you just arrived at right up above, and marvel at the power of math. It doesn't matter to me which of the two of them you do, just as long as it's correct. Some will prefer to stick with the first method because you don't have to memorize as much. It's the same process with both. Switch the sign, switch the sign. You really need to, with this second method, be very, very careful. And I'll show you an example of where you can get tricked up with the second method. Again, this is one that you guys should see, but if you don't, mathematically it should work out. And here it is. So option 1 is you see it right away. Right, Michael? Mm-hmm. Okay. Hold that to yourself. Just know it's there. Put it off in the margin. Like, smile at yourself that you have the solution with no work and you can move on. We're going to prove it with both methods. Method 1 that we did. I'm going to actually split this into 3x minus 1 is less than or equal to negative 17. Personal pet peeve of mine is when you then go ahead and write the statement on the other side, greater than or equal to 17. What's my issue right now with this line of work right here? What am I going to get a little bit poopy about? Note my G-rated terms here. What's wrong with this line? I did say write this and write that. What's missing? Laskov?
There's no and.
There's no and. It's kind of pointless unless you take this little symbol here and translate that into the word and. You'll have no idea how to join them at the end. So we get 3x is less than or equal to negative 16. X is less than or equal to negative 16 thirds. Still have an and joining. 3x is greater than or equal to 18, x is greater than or equal to 6. So here's my issue. On a graph, I have less than or equal to negative 16/3, and I have greater than or equal to 6. Well, and means overlap. What's the overlap of those? Yeah, there's no overlap. A number cannot be less than a negative and greater than a positive at the same time. So, Delaney, I know you see it. Michael, how'd you tell that right at the start?
Because it's less than, or it's greater than, 17 is greater than 3x minus 1, so it's only.
Well, careful, it's not that it's a less than. There's a reason that I can tell way up at the start that it's going to be an empty set. Andrew?
Negative 17.
What about it?
You can't have a negative on the outside. You can't go negative distance.
Can't go negative distance. Tie it all together with that inequality. Delaney?
An absolute value can't be less than a negative number.
There you go. Absolute value. You got to kind of be complete with your thought. Absolute value can't be less than a negative. By definition, an absolute value is going to be completely like positive or zero. So positive or zero number cannot be less than a negative number. That won't make sense. So that's one way we could show it. Way up top, we see this and we say empty set. We've got this. Can I show you the final way that may make that method 2 mess up unless you're really careful? The final way is if you actually do write this 3x minus 1 is less than or equal to negative 17, and you put a 17 on the other side. That's a logical fallacy right there because you're saying 17 is smaller than negative 17. So that should be an empty set. What I will have people do is say that this means it needs to be in between negative 17 and 17. And that's not what that's saying. Don't say that. The way you can tell is if you ever write this, look at that, try to match it with that and realize you made a mistake. You didn't completely get the original one down correctly. That's not what this is. Okay. We have 2 more and then we're done. Time check. 10 minus 4, absolute value of x minus 1 greater than 0. This is just another case of where I need to be very careful about how I do this. So heck, I'm just going to go ahead and do it. We have 6 times 10 x minus 1 is greater than 0. Divide both sides by 6. You get x minus 1, right? Because 10 minus 4 is 6. Andrew, what's wrong?
It's 4 times x minus 1.
Yeah, I failed in absolute or in order of operations there. Did you catch that? Be careful. You go too fast, you may do that too. You can't just add these numbers in front. That's not really a negative or minus 4. This is 4 times all that. That 10 needs to be moved over to the other side. We're undoing things in reverse order. So this is going to be negative 4, absolute value of x minus 1 greater than or equal to negative 10. Then divide both sides by the negative 4, causing your sign to switch. 10/4 is 5/2. This works. We have an absolute value less than a positive number. I can kind of think this means between. We can make life a little bit easier by not only writing this statement underneath, but putting the other side of that over here. And your only last step is to add 1, which I think of here as 2/2. Plus 2/2 plus 1 plus 2/2, then you don't really have to think. Negative 3/2 less than x less than 7/2. All x. Braces and circle. Okay, finally, there are some problems that we kind of have to hack to make it look like we want to. Here's an example of that. It is best when x is first. When it's not, you can actually get a little tricked up on how it plays out. We can force the x to be first. This is something you guys are going to deal with a lot in the coming years with transformations of functions. We really want to have the x first. So I can force the x to be first by just using small little pieces that you guys have learned over the years. For instance, if I want to switch the order of 6 minus x, I can. I just make it negative x plus 6, right? That meant the same thing. That's moving things around just a little bit. But now I hate the negative in front of the x. That's what's bothering me. That's really what bothered me right here. They have the negative in front of the x right here. So we can f-word that out of here, right? Sophomore, what does that mean? Factor. Pull the negative out, make it negative x minus 6 is greater than 0. I'm going to do this a little painfully slow so that this process is down. That negative is really a negative 1 times all this. And if that negative 1 is going to sneak out of the absolute value, we have to actually apply the absolute value. The absolute value of negative 1 is 1. So it comes out and it disappears. And you get the absolute value of x minus 6 is greater than 0, which actually means that these two statements must be the same thing. And they are. 6 minus x and x minus 6 inside absolute value are exactly the same number. Subtraction can happen differently in absolute value and still give you the same thing. Because, you know, your operation is cleaning up any negatives that are on there. So this is a better form. And I want you to get to the form of something where you have x minus a something in absolute value. We want that. And you can arrive at that. You can achieve that without too much difficulty. Now we're going to split it. X minus 6 greater than 0. Greater. We're going to write the word or down. X minus 6 is less than a negative 0, which I just call 0. Same rules. This means x is greater than 6 or x is less than 6. May seem weird. This is what the graph looks like. Just an open circle at 6, but that's fine. How many pieces to that graph are there? How many discontinuous pieces are there? If you were drawing it, how many times do you have to lift your pencil? Once. How many pieces are there? 2. They're 2 separate pieces. There's a gap in the middle. So your set notation should also have 2 pieces. X is less than 6 or x is greater than 6. That's the 2-piece way to do it. And I want to circle the word or and remind you guys that this word or comes from that greater. And if you really want to play your memory tricks, greater. There's one more way to write this in set notation. Just one other way that you should know. You can say this, x is less than 6 or x is greater than 6. There's actually a kind of elegant way to also say exactly the same thing. All x such that. Look at what the number line's doing.
X can equal 6.
Yeah. You can say that as well, and it means the same thing. Either one of these are fine. Yes, Andrew?
But why is it not all real numbers?
Because x can't be 6. We can't say 6. If I plug 6 in, you would get 0 is greater than 0, which isn't true. If it was greater than or equal to, it would be all real numbers. Because then you would do exactly the same process. You put a closed circle there, and you just say the whole thing. Okay.